Okay, hi. Thanks for having me here. I'm Gai Gutherz from Tel Aviv University and Babylonian Engine project. I'll be speaking about our main research that we did. That was basically automatically translating Akkadian to English using NLP, natural language processing. So I will start by talking about what is Akkadian. Okay, so Akkadian is an ancient language, one of the most important ones. From the 4th millennia BCE, it was, people started to speak it, and we have over 2,500 years of documented text in Akkadian. It was the language of many empires in Mesopotamia and the Middle East. It was written, it is written in cuneiform. As you can see, it's little signs, as you can see on this tablet. Okay, maybe now you hear me even better. Okay. So Akkadian is, as you can see, was in ancient Mesopotamia, all over the area. And it's a Semitic language. It's specifically an East Semitic language. Babylonian, Assyrian are dialects of Akkadian. So they use the same cuneiform, and sometimes it's a bit, the signs are a bit different, but they are same concept. And other Semitic languages we know are Hebrew, Arabic. But yeah, the East Semitic languages are mostly extinct now. Okay, so let's talk a bit about what is the problem, what is the challenge. So we have hundreds of thousands of Akkadian tablets that document the first days of history, but many of them are still unpublished because the process of translating Akkadian is very difficult. Only a very limited number of experts can read Akkadian. Okay, it's like only maybe a few hundreds or thousands people around the world. And the process is very long and slow. It could take weeks or months of work. And many of the tablets are broken, have holes, or are out of context, so it's not easy to work with them. Okay, so let's talk a bit more into details about how it looks like, how translating Akkadian is. So this is a digital representation, digital picture of an Akkadian tablet. And the first step of translating it is using a hand copy and recognizing the cuneiform signs and giving them some digital representation, like using Unicode, for example, in the computer. And then researchers use transliteration, which is a step in the middle of the translation, which is representation of the language written in Latin script, Latin letters, which represents how to read the Akkadian, okay, and what are the words. And the final step that is also historically manual is the translation, okay, to write what it is, what the sentence means in English. Okay, so why is the reading of Akkadian so complicated, you might ask yourself. I mean, it's just like a language like any other, but it's very different than the languages we know today, because each sign can be read in a few ways. First one is a logogram, that one sign represents a word of, for example, dingir, which is God in Akkadian. The other type of reading is phonetic, that a sign represents one syllable, meaning a part of a word. For example, an, just a syllable, one syllable. And the third option of reading a cuneiform sign is as a determinative, which means it's a semantic classifier of what type of word is the next one. For example, determinative could be that the next word is a god, is a name of a place. And even you can have one sign, one cuneiform sign could be a few different logograms or different phonetic syllables. Okay, so what did we do? So the first step of the research was using the digital representation of Akkadian, using the cuneiform signs, and managing to do the transliteration and the segmentation. Segmentation meaning deciding where a word ends and where a new word starts in the transliteration. And we reached up to 97% accuracy. Previous research reached around 40%. It was published in PLOS One. I think that was almost 3 years ago already. Let's talk a bit about the data set. So I personally think that the most important part in NLP and AI research in general is probably the data that you use. So we used mainly the royal inscription of the Neo-Assyrian period from Aurak. Aurak is an online database of Akkadian texts. So we managed to obtain more than 23,000 lines. One of the main challenges in Akkadian and ancient languages in general that it differentiates it from modern languages is that there is a relatively low amount of examples and data. So when you see translation from, let's say, Spanish to English, you have like, I don't know, tens of millions of examples, so it's a much easier task. So I would say that in this type of research of ancient languages, each new data set, each new collection that is digitized helps a lot because it makes it easier to train a model that actually can translate the language. So yeah, I was talking about the digital corpora and its importance to the research we did. And yeah, I would say that totally the more data there is, the easier it is to reach like real models that can generate good translations in high quality. But definitely the low resource was the main challenge in this type of project. So this is an example of the output. So you see that this is cuneiform represented in Unicode, and then you see the gold translation or from the data set, and the lower part is our translation. So as you can see, the transcription is very similar. I won't read it because it's probably won't mean a lot to most people here. Okay, so that was just the first part of the research. At this point, we wanted to go over the entire goal, like the full translation. So you see the diagram from before. So we tried 2 different paths to get full translation. The first one was from transliteration to translation to English. We called it T2E, transliteration to English. And that is a complementary step to the first one, right? We did from cuneiform to transliteration, so we said, okay, let's do transliteration to English. And the second task we tried to do was directly from cuneiform to English. That is C2E, okay? And that is, it's a major step because researchers of Akkadian and Assyrian, Babylonian usually go through the transliteration process. So we tried to go directly all the way from cuneiform to English. So this was, as far as we know, it was the first attempt, at least published, to do automatic translation of Akkadian and its dialects. We managed to obtain high quality translations this way, and what was impressive and what was a bit surprising to us is that we managed to go all the way from cuneiform to English directly. So we didn't need the transliteration in the process. The results were very similar in the quality, and it was also published in PNAS. Let's talk a bit about the dataset challenges. So as I said, data is the most important part in machine learning and NLP, definitely. Alignment inaccuracies. We had some sentences that were not well aligned in our data set between the cuneiform signs and transliteration or English. So we could have translations, like we could, in the training, that we just have one more word in English that doesn't make sense and doesn't belong to it just because the data set wasn't aligned well. So the quality of the data set is super important, not only the amount of it. Broken segments, this is an example of a broken tablet, and you can see it's very hard to understand like what's going on the right side of it. And different genres, it's also very challenging because Akkadian, like you have royal inscriptions, you have literature, astronomy, military descriptions from many types. So genres are very different, and we try to translate all of them to some extent. So this is just an example of translation. This is from transliteration to English. So HD is the human translation, and NMT is the neural machine translation. So you can see that it's not very far off. Yeah, the human translation is if the day of disappearance of the moon reaches its normal length, the days of the ruler will be long. The machine translation is if the day reaches its normal length, a reign of long days. This is another example, which is actually, it's closer in the wording, but the meaning is opposite, right? So it's on the 21st day, the king does not go down to the house of God, and the machine translation it's the same sentence, but without the not, like without the does not. So just shows you how difficult it is to reach, like perfect translation. So this is an example of a translation that is very close semantically, but still has like the opposite meaning of what was intended. Another problem is hallucinations. I mean, anyone who used like ChatGPT, for example, knows that sometimes it says things that are not related in any way to the question or to truth. And we also have those problems of hallucination. It's a problem in AI specifically. This is, neural machine translation is a subject of generative AI in the end, because we generate text, we generate English. Okay, so what are the conclusions from our research? So this was the first end-to-end translation system from Akkadian to English, at least to our knowledge. Our method, we showed that transliteration is not required for machines. Like the quality of translation is the same if you use transliteration in the middle or not. It works best with short and middle length sentences. So whenever we try to translate very long cuneiform text, the results were less accurate. Also, the genre is very, very different results. The more technical it is, when the style is more technical, it's just easier to translate. Like poetry is more difficult than, I don't know, a military text that describes like a king and his conquerors. And in the end, I think we didn't intend to replace the human in the loop or the researchers. So it is used now as a complementary material that researchers use also for educational purposes in universities for students, and also just for really translating real new Akkadian cuneiform tablets that are still found, and still many hundreds of thousands are still unpublished and untranslated. And a bit in a more high level. So I think this is a very good example of a use of artifacts that are digitized for machine learning and AI. I personally think that we're just at the beginning of an area of there's a lot to do, many tasks, and we're just at the beginning. We'll see many more advancements in the future, and it really depends on the data set that we have and the digital collections that are available for researchers. And also, as I mentioned a bit before, I think that not only digitation itself is important, but also accessibility. I think that we managed to reach good results because we had enough data set available for us, enough corpora, and the quality, of course, of the pictures, of the text. We had to work a lot with alignment problems. So also the accuracy, the quality of the digitized corpora online really helps doing machine learning and AI. Yeah, and do more AI, machine learning. That's it. Thank you.